Okay, good afternoon. Oh man, it's the post-lunch lull, isn't it? Okay, so my name's Richard Blewett, and I'm going to be spending the next hour or so talking to you about the new stuff in WCF 4.5. So, as you can probably tell, I'm from the UK, and so there's something we need to get out of the way straight away. Are there any Germans in the room? We feel your pain. We too were knocked out by Italy in the European Cup, or European Championship. Is there any Italians in the room? Okay, we don't know what it feels like to knock Germany out of the European Championship. We've tried many times, we've never done it, so kudos. Okay, I promise I will not talk about football for the rest of it. Well, maybe very slightly at one point. Okay, so what are we going to talk about? I'm going to start talking about what the big picture, what the goal of this release of WCF is really for. Okay? And it's really two core concepts: simplification, which is a job continuing from WCF 4.0, and then also looking at trying to bring the communication stack up to date with things that are developing since the release of WCF in 2006. So back in 2006, we had the initial release, which was the core functionality of WCF. However, obviously there's been a number of releases since. We had in 3.5, this was when we first got the sort of the web programming model with the web get, web invoke attributes. We had the web HTTP binding for doing sort of REST style services. In 3.5 Service Pack 1, we got POCO support. In other words, we didn't need to attribute classes with data contract to get them serialized anymore. Helped with migration, for example. The big next chunk of real sort of core functionality came in version 4, though. In version 4, it was finally sort of starting to be dealing with the fact that people found WCF too complicated. Now, I don't know. I mean, does anyone find WCF too complicated? Surely not. I mean, okay. Specifically, before version 4 as well, there was the chances of making mistakes in configuration very easy. Simple mistakes to make would mean your service would behave very, very differently, and you may take some time to work out exactly what you've done wrong. I spend a lot of time on various sort of web forums, and very often before version 4, it was people not referencing various bits of configuration and they weren't coming active. And so it's certainly things like the default behaviors, that sort of thing, actually simplified the life of people actually working on forums, for example, for a start. But the other pretty big thing in version 4 was the routing service. We had WS Discovery as well, but probably the one that potentially impacts more people's lives is the routing service, this sort of pre-packaged SOAP intermediary which would allow us to do failover, multicasting, and probably most importantly, data-dependent routing or routing. So when we come to version 4.5, as I said, we have two core themes: simplification and communication. So let's talk about simplification first of all. It comes in a number of different parts. First of all, we continue the efforts to simplify the job of working with configuration files. Then there's the idea of doing contract first development. Anyone come across the idea of contract first? Okay, so contract first is essentially, I don't start writing the code to start off with. I come to an agreement somehow or get hold of a WSDL document that describes the service, and from there I build the service. Okay? I'll talk a bit more about that in a minute. There's the ability out of the box to do flattened WSDL. Again, I'll talk about exactly why that's potentially important in a moment. And probably the most impressive thing, I think, in this release in terms of simplification is making the asynchronous programming model far, far simpler in WCF. So let's talk about configuration. We obviously had a whole bunch of stuff that was done in version 4 along this path. So default endpoints, default binding configuration, default behaviors meant the ability to reduce the amount of sort of effort we had in building configuration files was hopefully significantly reduced. It did actually bring some of its own issues as well, particularly default endpoints, bring a whole world of other issues that sometimes need to be addressed. But in terms of simplification in many situations, particularly when people are first starting out learning WCF, it certainly helped. In 4.5, there's a couple of things that have happened. First of all the changes, really, or majority of changes in version 4 affected the server-side configuration. Well, the client-side one, you run as service reference and you just don't look at it, because if you do, there's so much XML in there, you go blind, basically. It's like, so essentially, we did, it was really concentrating on server-side. In 4.5, they've addressed client-side, so now you only get the XML you actually need generated on the client side, or pretty much. There's also trying to make just purely the editing experience inside WCF configuration files a bit simpler. So, for example, you'll see there's tool tips and things like that on the configuration elements. So at least there's some notion of what these various items actually are meant to be doing inside the configuration, rather than having to keep going back to help files or onto the web to search. So contract first. Contract first is kind of important broadly in two big areas. One is when you're trying to achieve significant interop with other platforms. See, the problem is if you start from the code, there's a very good chance, if you're not careful, that you will bleed some .NET specific type into your contract. Okay? Which is very, very hard or potentially impossible to consume from other platforms. Dataset is sort of the poster child for this one. Okay? So one of the things by starting with WSDL is, of course, there is no chance of doing that. You're starting with XML-specific types, schema-based types. The problem is, of course, how do you go from that WSDL document to the actual code? Now, if we go back to the days of ASMX web services, you could run WSDL.exe with a /s switch, and it would generate you a skeleton of the server-side code. But we haven't had that ability in WCF until now to do something similar. So the other situation where this becomes important is some infrastructures, like Salesforce, for example, give you the ability to implement a service that looks a specific way, tell Salesforce where it is, and they'll start firing notifications via web services to you. Okay? Now, obviously, they're not going to give you the code. They're going to give you a WSDL document to describe it, because they're not going to say, you must use this technology. It's the idea of services. On that basis, we again now have a WSDL document which we need to take through into code. Okay? So, Service util from 4.5 onwards has a switch /s/service contract. You point it at the WSDL, it generates you just the service contract and the data contract, message contracts, that sort of thing. Okay? It doesn't generate you proxies or all that. It just generates you purely the things you need to then implement the service. Okay? Okay, now, flat WSDL. The default model in WCF is to take the description tree of objects from the service host and walk them and generate the WSDL on the fly. Okay? And there's two very important things it does. First of all, if your service contract and your binding are not all in the same namespace, it generates multiple WSDL documents with WSDL imports. And it always generated schema imports for the message structure that you were using inside the messages. Okay? WSDL imports themselves are problematic because some other toolkits, some other platform toolkits don't actually support them, even though they're a formal standard part of WSDL. But if you're careful about your namespaces, you can get rid of that model. Yeah? You can get rid of the fact there's schema imports or WSDL imports. The bigger issue is really we couldn't get away from schema imports. And this particularly becomes important when you have potentially complex network topologies. It's very easy for those schema imports that end up in your WSDL document to actually end up with non-routable addresses in them. Okay? So if we just have a single file with everything in it, we get around this problem because as long as we can get to that WSDL document, we have everything we need. And so endpoints, as well as the old question mark WSDL switch, now have a question mark single WSDL switch, which brings everything into a single document. Okay? Again, we'll see this in a second. Okay. This, though, I think, is the thing of beauty, one of the things of beauty in WCF 4.5. It's not as if we've never been able to do asynchronous work in WCF before 4.5. It's always been there, okay? We've always had it there on the client side. We've always had it there on the server side. Who's invoked a service asynchronously? Okay, so there are a fair few people. Obviously, this is a blocking operation, potentially time-consuming. If you're writing a user interface particularly, but also important in, say, web-based applications as well, but particularly if you're writing a user interface, you call a service, you do not know how long it's going to block for, and if you've got things like certificate validation going on, it can be a noticeable amount of time, especially on the first invocation. Okay? We don't want to block during that invocation. Now, the problem is that the synchronous programming model and the asynchronous one look very different prior to version 4.5. So prior to version 4.5, well, prior to version 3 of WCF, we essentially had two models we could work with. Okay? We could use APM, the asynchronous programming model, which is essentially the async result, begin and an end method. Okay? Or we could use the event-based asynchronous model as well, EAP. The problem is with those is twofold. APM, begin, end, and async results, doesn't help you get onto, if you like, the correct thread when the operation completes. You have to do that marshalling yourselves via some like synchronization context or some sort of structure like that. It also, obviously, your code is structured very differently from the synchronous model because you have to wire in some kind of callback, okay? Well, at least generally. You can poll with a timer, but it's far more robust to use a callback. But it runs on a worker thread. You cannot touch user interface stuff with it. EAP, similarly, is a model which diverges from the synchronous programming model very heavily. Okay? The code looks very, very different. So you have to, if you can't easily just flip from synchronous to asynchronous, you have to restructure the code. Okay? Fortunately, it does actually handle the thread marshalling for you on the events when it completes, but essentially we still have the issue of the code looking fundamentally different. Although it wasn't that hard, I guess, to do client-side asynchrony. Who's implemented an asynchronous service? Now, I can see about 3 or 4 hands go up. Considering like maybe a third of people, maybe more, actually put their hands up for invoking a service, implementing one asynchronously is a very, very different matter. Okay? In the simplest case, actually, it's not very hard. The problem is as soon as you want to do more than one asynchronous thing on the server side, life gets much more complex for you. You have to essentially have some way of signaling some sort of composite asynchronous operation is completed. Very commonly, this would mean implementing our async result yourself. And so there's a bunch of plumbing you had to put in place. So the question is, why would you want to do asynchrony on the server? And it all comes down to scalability. We have request threads. We have request threads that are coming in, and we want them to service requests. If we go off and do some long-running blocking I/O-based operation, we are reducing the scalability of our service. Okay? So ideally what we want to do is if we have to go and do I/O, we hand off to an I/O completion port and we get back the request thread to service more requests. Obviously, when the I/O completes, we then can return to the client. But while the I/O is taking place, we can handle more requests coming in. So very important if you're trying to handle very scalable server-side software. And it was just hard. That was the fundamental problem. It was hard to write this stuff well. Okay? So in 4.5, the task-based idea of asynchronous programming introduced in .NET 4 is wired now into the world of WCF, both on the client and on the service. The client side, the proxy, automatically generates. You don't have to go into advanced settings and check a checkbox. It just by default generates you the asynchronous model now. And it's all, by default, task-based. So, on a contract, as well as having this get tweet count that returns an integer, it would also generate a get tweet count async that returns a task of int. Okay? Who's seen the new async and await functionality in C# VB.NET? Okay. This is hugely important for that. Yeah? We return tasks, suddenly our life becomes really, really simple. Now we're using one of the new compilers. Okay? But on the server side as well, again, we have a very straightforward model. We elect to say we're doing asynchronous work by changing the signature of the operation in the contract to return a task. This doesn't affect the client. The client still sees it as returning an int. This is about the server-side implementation. Okay? So we basically say we return a task event, and then the operation has to return a task event, which means we can use async and await internally, which means when we go off and do our blocking operations, instead of blocking, we simply use await. The method returns, the request thread is released, and then the next request, and then eventually, when that finishes, continuation runs and returns the data to the client. Okay? So let's use some code here. So I've got a few projects here of various sorts. Here's async. So on the async side here, we're going off to Twitter with a particular search string, finding out how many matches there are on that search string and returning the count of matches. Okay? Obviously, going off to Twitter is a I/O-based operation. It's potentially long-running, depending how busy Twitter is. Okay? We don't want to block the request thread. At the moment, all this code is synchronous. Okay? So it returns an int, and we simply have some code in there printing out the thread consumption. Okay? So let's run the server side. There's also a GUI client in here. Okay? The GUI client at the moment, if we go to the view model, is simply making a synchronous request. Okay? So the service is blocking, going off to Twitter, so this is going to be a blocking operation. Okay? We're on the UI thread, so it's going to block the UI thread. So if we run this, so I don't know, hash T12. When I hit search, you can see the UI doesn't respond for a few seconds, and users don't like that. Okay? They don't like their user interfaces continuously blocking as they're trying to use them. So what we want to do is introduce asynchrony on the client. But let's have a look at what happened on the service as well. Let me just bump the font up on that a little bit. Okay. So when the request came in, WCF requests are dispatched on I/O threads from the thread pool. So we can see that we went down to 999 threads in the I/O thread pool. Okay? So while the request was taking place, 999. And then we went off to Twitter. This is the timer kicking in. Okay? We're still consuming the request thread here. All the time we're out talking to Twitter. Eventually the request comes back, and, well, this is the last one. The time is finished, so we go back at 1,023 threads for the worker threads, because the timer was consuming one. But essentially, we are still consuming the request thread until we go back. Okay? So let's sort out the client side first. If we go to let's just go and add a service reference. We're not going to add it, but just so you can see how the defaults actually work here. Okay. If I go to advanced, notice that allow generation of asynchronous operations is checked by default, and it defaults on the task-based operations. So if I don't do anything, I get asynchronous bindings into this. Okay? So what I want to do here is change this so I don't block during that operation. So fortunately, we have an async version of the method, okay, generated for us. Now, this obviously doesn't return an int because the async version doesn't complete until later. However, because we're using C# version 5 here, if I use the async keyword on the method and the await keyword on the operation, essentially now I'm now doing fully asynchronous. Now, the beauty of this model, though, is the async code looks almost identical in structure to the synchronous code, so it's hopefully very understandable to people reading it. So with that one small change, I rerun the client. Or maybe, first of all, I kill the old one. And this time, when I do a search, I can move the client around immediately. Okay? I suppose you do some different ones, we get a different result, potentially. That will definitely get a different result. Twitter only returns about 100 or so results. Okay? But essentially, everything now is asynchronous on the client with very, very little change. Okay. That's okay, that's the client side. What about the server side? How do we release that request thread we were using? So if we go back to the server, and this time we have the call to get response here. Okay? I want to call the asynchronous version. And again, this returns a task, so I await on the task. I mark the method as async to allow me to use the await keyword. Oh, I've got to change the contract, yeah. Where are we? And obviously now, because this is asynchronous, I change the contract to use task, so I implement it as task. Okay, so I rerun the server, I rerun the client. And we go and look at the server side now. As soon as we go off, obviously as the request starts, we consume a thread, yeah, a request thread. But as soon as we head off now to start working with Twitter, we release the request thread for anyone else to come along and start using, and only reconsume it when the I/O completes. Okay? It's a very, very straightforward model for doing asynchrony on the server side and the client side. Okay? So, that's simplification. Oops. Let's talk about modern communication. See, the world has moved on since WCF was first released. There were certain things that were there in the world before WCF was released which weren't actually packaged up neatly into the WCF world, and there are new protocols that have come along since as well. Okay? And in fact, new types of clients with different demands. So, first of all, in the world of Metro, life is very different from a standard client. First of all, we do not do blocking operations. Anything that takes more than 50 milliseconds is meant to be asynchronously invoked. Okay? Now, WCF calls can quite easily take more than 50 milliseconds. Therefore, when you generate a proxy in the Metro world, there is no synchronous version of the invocation. Okay? Secondly, they've done something very neat with duplex binding. Previously, for duplex, we had to implement the callback contract, create an instance, wrap it in an instance context, hand it to the proxy. It wasn't horribly hard, but it was more work than maybe we needed to do. What they do now is take the methods on the callback contract and surface them on the proxy as events. Okay? In terms of what functionality in WCF we have available, we have basic HTTP binding available, obviously web HTTP binding because it's HTTP. We have net TCP available. Okay, so if we want to do sort of fast sort of calls using TCP, we can. Obviously, we're heavily session-based at that time, and potentially we're not going to be firewall friendly because we're going to need a port opened. And then there's this new thing, net HTTP binding. This is a new binding for 4.5. Now, there was a sample called the NetHTTP binding sample, which basically did binary encoding over HTTP. And part of what this one is a productionized version of that. However, as we'll see in a minute, there's a bit more to it than that, which is pretty cool. The other big thing about Metro files, Metro applications are apps you download from the store. You don't want someone playing around with a configuration file once you've downloaded it, changing the settings. And so there are no configuration files for Metro applications. Okay? Instead, the generated proxy code has addresses and that sort of thing wired into the generated proxy code. And also, if you want to change the default settings, maybe you want to change the send timeout, for example, or maybe you want to sort of wire in how authentication, how maybe a certificate's discovered or something like that, then you override a method called configure endpoint. It's a partial method, you provide an implementation for it, and essentially that's what actually does the alternate enterprise behaviors and that sort of thing. Okay? So we'll see this in a minute as well. We've also got packaged up support for UDP. Now, this has been a long time coming in many ways. There's been a sample there for years for UDP. Okay? But it was never fully robust. It was never productionized. It wasn't supported. What we have now is a fully supported implementation of the SOAP over UDP standard. Okay? So, why UDP? You know, we're very happily sitting there with TCP. My timer's gone weird. We're very happily sitting there with TCP. Everything we've done pretty much so far has been over TCP or maybe queues. Why UDP? Well, first of all, it's connectionless. It's connectionless and unreliable. You think, well, why is that a good recommendation for it then? It means it's fast, okay? Because we're not under the covers doing all the network acknowledgements backwards and forwards that TCP requires to ensure reliable delivery. It also obviously means it's not suitable for everything. If you absolutely need the data, do not use the UDP binding, okay? However, there are quite a few applications where the important thing is about the fact we're able to have a lightweight way of receiving, and if we miss the odd message here and there, it's not that big a deal, okay? So it depends on usage. Certainly I wouldn't say this is the only binding you'll use from now on. That's certainly not true. But it's a very useful one for certain scenarios. One of the big things it can do is it can do true broadcast, which you cannot do. I mean, I know the P2P binding kind of pretends it's doing broadcasting behind the scenes, but all it's doing is asynchronous invocation of each of the things in the net in turn, okay, each of its neighbors. This is true broadcast. So it's an implementation of the SOAP over UDP specification, which means it's text encoding, angle brackets on the wire, and has what may be quite a surprising naming scheme for the address, which is soap.udp. Okay? So, what sort of things can you do with this? So imagine you've got an airport terminal, which seems to be a feature of my life quite a lot at the moment, and you've got on the boards, you've got all the flight information. Okay? There's updates happening to flights all the time. If we send the updates every couple of seconds, does it truly matter if one of the boards misses one of those updates? As long as we have a way of making sure that all the information is always available in some way, it doesn't matter. Okay? What it does mean, we can bring on as many boards as we like, and we don't need to tell anyone they're there because they just listen for broadcasted traffic. Okay? So, in this point, what you might conceive as the client, the thing receiving the broadcast, is actually obviously the service here. It's the thing listening. Okay? So, I've got a contract here somewhere. So this is using a one-way contract. If you're going to do broadcast, it doesn't make a lot of sense to use the request response. Which response am I going to be using out of all the things? I mean, it does actually work. You just get the first one that comes back. But it isn't really the that's not really the purpose for this. Okay, using a one-way contract for true broadcast. And then if we look at our view model here, we can see that essentially it creates a thing called a flight service. And inside here, we essentially start listening using a service host and just getting all the flight details that come pushed to us, okay? And binding them up to the listening UI. On the other side, we've got a flight broadcaster. This is just a console application. It just basically creates a flight manager, allows us to start listening, and the flight manager just starts sending flight status out. The important thing here is the fact we're using a UDP broadcast address. Okay? UDP defines a number of addresses that are specifically designed for broadcast. Okay? So if you're listening on one of those, you know, you're just listening for any traffic that happens to be broadcast. You're not looking for specifically directed to you. Okay? So we can work with this slightly more easily. I've got them both on the desktop here. So if I go, let's say, start the broadcaster. And let's create a couple of flight status clients. There's no flight information coming out at the moment, so let's just get a couple up and running. And now we start broadcasting, and it's truly broadcast to these. Okay? The nice thing is, obviously, you're speeding things up a bit here. Flights hopefully don't sort of start boarding and close that quickly. It would be a bit mayhem inside the airport, wouldn't it? But I can bring others on board. Just put a new board up. I don't need to tell the broadcaster about it. It doesn't need to know to start sending to this one. It just starts listening for the broadcasted traffic. And in fact, they can all go away, and the broadcaster, because it's truly connectionless, it's not, then doesn't care. It's still just broadcasting information out there. It doesn't care there's no one there to listen. And then, as we have listeners come on board, they just sit there and accept the new information coming on. Okay? We didn't have that ability in any supported way prior to version 4.5. Okay? Okay. So, WebSockets. This is a new standard. So UDP is a really old standard. WebSockets is a new one. Okay? WebSockets, the idea is trying to get a better model than purely long polling for saying, I want callbacks over HTTP. Okay? The important thing is here, we can happily use port 80, port 443, the standard HTTP ports, very firewall friendly, to essentially park a connection. And then the requests can then be fired back along that connection. Okay? This has all been packaged up as part of HTML5. It's not something specific that Microsoft are doing or anything like that. This is an agreed standard. If you look at the browser support, Internet Explorer supports it, Chrome supports it. I think Firefox does. I'm not sure about Safari. But certainly, as the newer versions of the browsers all support the idea of WebSockets, which means I can have JavaScript clients which are receiving notifications coming from the server. Okay? So, the only problem in terms of WCF 4.5 is this requires operating system support. Okay? It's not there in Windows 7, Windows Server 2008 R2. You are going to require Windows Server 2012 to be able to run a server that is going to be sending WebSocket information. The other thing is that the core underlying sort of plumbing is actually relatively low level in the channel layer. Okay? So out of the box, if you want to talk to JavaScript clients, then you have a bunch of fairly low-level plumbing to work with. Fortunately, there's a NuGet package that actually wraps this all up very, very nicely, mirroring the JavaScript WebSocket standard API. okay, giving you the server-side reflection of that. So, WebSockets to the browser. Okay, so the WebSocket API is relatively straightforward from the browser. Who likes JavaScript? Well, there was some brave souls there. It was not. It was. If you're at the front, there weren't many hands, right? Okay. So if you're not used to looking at it, I apologize. This is kind of. It's not my most natural language. So if you're a JavaScript expert, you may start shouting. You shouldn't do it like that. I know. Okay. I was just getting a demo ready. Okay. There are better ways than structuring the JavaScript code. It's just purely just trying to show you sort of how this sort of thing works. Okay, first of all, it has a unique addressing scheme. So instead of using HTTP, we use WS:. Okay? But it still can use quite happily port 80. I'm using port 9000 here, but you can quite happily use port 80 as well. Okay? Okay, so essentially, you create yourself a WebSocket. This is standard. This isn't something unique to a Microsoft implementation. I think it's a standard WebSocket API. You create yourself a WebSocket, and then you sit there and you wire up a bunch of events, essentially. So you say, when the WebSocket opens, we're going to do a send in this case to start triggering the data coming back. And then when messages arrive, then I want to do some stuff. Okay? Not exactly complex. Yeah? Okay, so what does a server side look like? As I said, we've got a NuGet package here. So most of the hardware work's done inside the NuGet package. There's a special service host called a WebSocket host, okay, which basically packages up the listening model for WebSockets. We add a WebSocket endpoint based on a WebSocket start address. And then, but essentially we have on open, this is when the client connects. On send, so on message, this is again when someone sends you a message, okay? And then we have the ability to do a send. So it's the reflection of the JavaScript API inside managed code. So it's really just two peers in many ways. It feels like talking to each other using the same API. Yeah? Now, obviously here we have a request come in. We don't want to consume a thread the entire time we're doing processing, sending arbitrary things back, okay? So again, asynchrony is hugely important on the server side when you're talking about WebSocket programming. We don't want to be blocking. When we haven't got anything to send back to the client, we don't want to be consuming a thread, because this would make WebSockets massively resource hungry and very non-scalable, okay? So all we do here, this is basically doing stop movements. We go and get a stop movement and send it up to the client. Then we wait for briefly. This is a non-blocking wait, task.delay. This is, okay, so this basically releases the thread and then recommits it after the timeout. It's not like thread.sleep. Okay, so if we run the server side then, and then we bring up the website. Essentially, we're firing events into the JavaScript. Okay? So it gives you so this is, if you like, sort of SignalR. This is the sort of technology that SignalR starts layering on top of when WebSockets support is available. Okay? So, new communication models. But it's not very WCF-like, is it? We've lost our service contracts and stuff like that. It's very nice that we can integrate with this, and this is, if you've got JavaScript clients, this is kind of what you're going to have to do. But it'd be kind of nice if we could take this model and layer in WCF-style support over it, because we've always had a bit of a problem doing duplex in WCF. There was this binding that kind of masqueraded as a sort of supported standardized way of doing duplex over HTTP called WS dual HTTP binding. Who's used WS dual HTTP binding? Yeah, there's a few hands going up. There's a problem with this part of the is in the name there, dual. Because the problem with that binding is when you make a request over HTTP, what it does, it opens a connection in the other direction back to you. Now, this is all very nice when you're doing a demo on a single machine. If you get a firewall anywhere in this environment, this just stops working, okay? Because obviously, no firewall is going to accept arbitrary inbound connections to clients, okay? So the usage model, they're really, I spent a while trying to come up with a coherent model where this would be a better model than using NetTCP, which was pretty much our other option. And I couldn't come up with one. Okay? So, therefore, our alternative has been NetTCP. And that certainly works. You know, I've shipped systems with it. It works very effectively. But there's a couple of issues. First of all, I can't use port 80. Okay? So I'm using TCP traffic, stateful inspection, even if I did sort of sit there and hijack port 80 on a particular machine, didn't have a web browser or anything, and somehow managed to get it running over port 80, then I'd still have issues running because any firewall doing stateful inspection would get very, very upset with the traffic that was going across that connection. Okay? So generally we had to open another port. It was also, I mean, NetTCP in itself is, it's a connection-orientated protocol. It's very, very sensitive to disruption in service. Okay? So, for a couple of reasons, that it worked, certainly, but it wasn't ideal. It'd be kind of nice if we had a way of doing WCF-style duplex over this technology, because we have in use agreed standardized protocol. And if we have an agreed standardized protocol, but of course, firewalls and that sort of thing will start to understand that the protocol exists and start to be friendly towards it. But we can use port 80, so we don't have to open special ports or port 443. Okay? So when I said there was a bit more to NetHTTP binding than simply giving us a nice model for binary over HTTP, the other big thing it does, if you give it a duplex contract, it does WebSockets. Okay? Now, I guess a couple of things here. So, obviously, again, we're going to need Windows Server 2012 or Windows 8 in the mix to actually make this work. Yeah, so if you want to play around with this, you will need to be running Windows 8 or Windows Server 2012. If you're going to ship something on this, I'm assuming you'd have the server side not running on Windows 8, which would be a slightly odd thing to run on your server. You'd be using Windows Server 2012. But I guess we should briefly just talk about why the original goal of the the NetHTTP binding, this idea of doing binary over HTTP, is a good thing anyway. It's a very, very common binding for people to use. Okay? I've seen diagrams which are kind of meant to say, this is a situation you'd use different bindings. And there's always the firewall here, and on this side, outside the firewall, there's WSHTTP binding and basic HTTP binding and web HTTP binding. And on the inside of the firewall, there's NetTCP binding, NetMSMQ binding. Well, okay, broadly you could say that's a good first cut, but it really isn't the whole picture. Anyone use the Azure Service Bus? So one of the models that use is use essentially one flavor of NetTCP going through the firewall. It's not the only way, but that's one thing that it does. So it's certainly not to say you can't use NetTCP through a firewall. Okay? It does require to open ports, but that's not necessarily a big deal. It's also, why would you use HTTP inside the enterprise, inside the firewall? Well, for one thing, it load balances brilliantly. NetTCP struggles with load balancing because it's a connection-orientated protocol. If you basically hit a machine, you've got a hardwired connection to that machine from then on using that binding. Okay? You can't be load balanced onto another machine. So you have to turn on sticky sessions on a load balancer for it to work. Okay? So using basic HTTP binding seemed like a reasonably sort of valid model to use inside if you wanted load balancing to load balance freely. The only problem is, why do you want to spend the expense of doing big fat XML across the inside when you know everything's talking the same sort of language? Okay? If everything's .NET, why do you need to use something interoperable like XML? It just makes the payload bigger. And so using the binary encoder over HTTP was a very common route that people went. There was a sample there. It's very easy custom binding to build. Very commonly, people would sort of build it themselves. So it was slightly odd that we didn't have it there available anyway, okay? Because it was so common. The standard bindings are meant to represent common scenarios. This was certainly a fairly common scenario. So we've got that side of it is done. But probably the more exciting bit was the thing we didn't have before, which is full duplex over a single HTTP connection. Okay? So, Metro supports duplex over net HTTP binding, which means I can have my Metro client running on Windows 8. I can have my, over on my server, I'm running net HTTP binding based service, and I can fire event-based stuff over the WebSocket, underlying WebSocket protocol over port 80 very, very happily. Okay? Which means I can have responsive Metro applications, fast, fluid, taking updates as and when required, and not have to do polling and that sort of thing behind the scenes. Okay? So we're not in the world like we have with Silverlight with the polling, duplex binding. This is something which is very, very more neatly packaged and is truly the server firing events up to the client. Okay? Okay, so I said I wouldn't talk about football anymore. Unfortunately, this demo is football-based, so it's the football scores coming in. Don't worry, it's not the European Championship, it's just the English Premier League, so hopefully slightly less loaded, shall we say. Okay. I've got a couple of contracts. I've got one which is a fixture update which has things like firing notifications, say things like a goal has been scored, someone's had a yellow or red card, all that sort of stuff. Yeah, someone's been booked and sent off. So various events that happen in the lifetime of a match. We've also got a service which has the definition of the duplex contract, essentially. So this allows you to go and get all the fixtures, allows you to go and get all the current scores. It allows you to, and it just explains the start method to start the simulation going, I guess. And finally, it specifies it's a duplex contract. Okay? If we go and look at our, I've got this down here. So the service here. Okay, so it's just a normal WCF service. We don't need to do anything special in terms of WebSocket hosts or anything like that. We go and look at the configuration file. It's using net HTTP binding. Okay? But it's using an HTTP endpoint on port 80. Okay, so we get that up and running. And then we've got a Metro application. Now, the Metro application has a few things. First of all, obviously, we need a proxy. It's a standard WCF proxy. Okay? So the Metro side of things, it's standard WCF client side. There's a few tweaks to make it more natural with the Metro world, but it's the standard WCF client side plumbing. Okay. Now, there's a couple of things you have to be careful of Metro-wise, because Metro apps can be suspended. Obviously, if we suspend it, then our proxy is going to be not particularly useful in terms of duplex communication. And so if we already had a proxy, we want to get rid of it, uncouple ourselves from the proxy, close it down, and then start up again. So we have to take care of the fact there's other modes the Metro application can be on rather than running and terminated. Suspended mode and that sort of thing gives us other things to consider. Okay, so we wire up create a new client. Again, this is just standard sort of proxy-based code, but this is new. Okay, so here we're getting a new request coming through. This is a duplex-based request that's been fired back, but now it serves as an event rather than a normal method. We don't have to create an implementation of the duplex contract anymore. So I do proxy dot. We can see the fixture updated received. So fixture update received is an event on the proxy. Okay. Okay, where's my onUpdate received method gone? Here's my onUpdate received. Okay, so here we just get an event args that model the data that's coming back, which is a bunch of notifications that we then set up into the screen. Okay, well, and then, well, as I said, Metro has an iron law about asynchrony. Over 50 milliseconds must be invoked asynchronously, or anything potentially over 50 milliseconds, and that certainly is true of WCF requests. Okay? So, we have to call the asynchronous version. Where am I? Now, again, the beauty of async and await means it's very, very straightforward. This is one of the most important things in the 4.5 release, is the fact we have async and await. The whole asynchronous world, which is so important, there's so many types of applications, not just Metro, becomes very, very straightforward to build now. Okay. So, we populate, and then start async essentially just starts it running. So if I run now the Metro app, okay, so it's not doing anything yet. Okay, so have a little play down here. So I do play. It goes and synchronously, or goes and gets all the requests in a standard WCF request response model, but then we can see the various results coming in now, and the results coming in are being fired by duplex. Okay, so these are coming up as events on the proxy. Now, obviously, this is again slightly faster than real time. Matches last about 30, 40 seconds in this case, rather than which some of you think if only that were the case. But as you can see, we have a very fluid, responsive user interface. Okay? Okay, so, but that's not all, okay? There's a whole load of other things that are being done. You can say these things are the highlights, but some of these other things that are there, you might actually think are the highlights because these things particularly cause you pain. So, for example, streaming when you're doing IIS hosting has always had issues, okay? The time taken for the data to arrive at IIS and then to be delivered to your service has always been problematic with streaming-based WCF. It's now essentially you get it immediately from version 4.5 onwards. Okay? So they've done a lot of work in the streaming model to make it far more efficient in moving the data between IIS and into the service. We get configuration IntelliSense and tooltips. Well, I don't just mean we get IntelliSense in terms of schema-based XML editing, but we get actual for types as well. We can get IntelliSense. Oh, there's a couple of things I didn't show you. Let me, I always had this. When I was talking about WCF, there's always this one sort of like joke you guys do about the GUI configuration editor. Who uses the GUI-based configuration editor? Yeah, so a few people. How do you actually get to it, though? Well, that's always the interesting thing. When you right-clicked on the configuration file, it wasn't there. But if you went to the Tools menu and started it, and then closed it down again and right-clicked on the, something magically appeared. Okay? Well, unfortunately, they've ruined that joke now because it's just always there. It'd take all the fun out of it. Where are we? Yeah, so it's just there. Okay, so the mystery of where to find the WCF configuration editor has all gone away now, which is kind of sad. Okay. It also will do validation of configuration files on build. So you don't have to wait until you run for it to blow up to say you was something wrong, you missed something in configuration file. It will do validation of config files on build time. Especially if you have a build server and someone's checked the configuration file in, it's kind of handy to know they've broken the build before you push it out in continuous integration out into some sort of UAT environment or something. Okay? This one's fairly big as well. Who moves large messages around? Do you like the steps you have to go? Okay. Who just sets everything in the entire world to win.max value? I mean, it's pretty much, you know, eventually, if you're trying to move large messages around, there's this sort of model where you just keep on throwing configuration at it until it works, yeah? So just start increasing numbers on everything. No matter what its purpose is, just put the numbers up, and eventually it will start working, kind of thing. It hasn't been the easiest model because there are so many different quotas. Not only do we have the max received message size and max buffer size, we also have things like the size of graph that the data contract serializer will serialize. We have max string lengths, max array lengths. They're all there for specific reasons of trying to protect you from denial of service attacks, essentially. But of course, if you actually want to move some large data around, you have to keep on changing all these little sort of configuration settings. So now, for the quota-based, they've done the job that everyone else ends up doing. They put them all to win.max value by default. Okay? If you want to bring them down, that's fine. But essentially, there's still the throttle in terms of max received message size is still there. But if you decide to handle larger messages, the quotas aren't going to bite you unless you want them to. Okay? Finally, IIS. IIS hosting is probably one of the robust ways of doing. If you're doing something like basic HTTP binding, you'd be mad not to do IIS-based hosting. Okay, it's by far the most robust sort of hosting model for non-session-based binding. But there are issues with it. It's very hard to support multiple authentication methods. So if you turn on SSL and then you say, and I want a client certificate, you're going to find it very hard to have part of that that doesn't require a client certificate at that point, even if you really like one. Okay? So essentially, they've also now allowed multiple authentication mechanisms inside IIS. So you can support more than one authentication model. Okay? Okay, so two things then we've had with WCF and 4.5. Simplification and modern communication. Okay? One of them makes life easier, one of them makes life richer. It's probably functionally the most significant release we've had arguably since 3.0. Okay? There's a lot of functionality packaged in there, okay, that we didn't previously have. So, lots of resources. There's obviously the TechEd website, Microsoft Learning, courses, TechNet, and probably for the stuff we can talk about here, MSDN, loads of information there. There's a great series of blogs a guy called Ido Flatto wrote on the new stuff in WCF 4.5. Go and check them out. I think they're on Code Project. Please, 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 I know you hear this every time, but please fill out your evaluations. You can win swag. Okay. Okay, so. Any questions? Thank you very much for coming.